Welcome back. Hydroelectric power is crucial in the Northwest. Cameron has the latest on how water powers the entire Northwest.
In the past years, I've looked into the safety and efficiency of the Fern Ridge Reservoir. I've talked to the Corps of Engineers and several hydrologists about the typical rainfall here in the Willamette Valley and how we know when our waterways are getting near flood state. I've learned how we can forecast for those conditions and how we regulate flow rates to prevent them. All of these topics have a single important through line: dams. Damming in the valley is handled by the Army Corps of Engineers and has its roots all the way back in the 40s when the first of our dams, the Fern Ridge Dam, was completed in 1942. The initial primary function of these dams was for flood management. Of course, this function has been successful, with the Corps reporting a total savings of $25 billion of destruction since their completion. But a second function of these dams is becoming equally as important: hydroelectric power. Of the 13 total dams operated in the Willamette Valley dam system, 9 have the facilities and equipment necessary to generate hydroelectric power. In total, 13% of the United States power supply comes from hydropower. It's also a nearly completely green form of energy.
So, how does this all work? Well, it's actually pretty easy. Physically, this is an application of Faraday's law of induction, which essentially states that if you take a magnet and move it around a coil, a metal coil, it'll induce an electric charge into that coil. So what that means practically is we need to take the movement of water through the dam and turn that into movement of a magnet. Well, that's exactly what our turbines do. As the water passes through and over them, they rotate, and that is linked to a magnet in the generator unit, and that then passes around a coil and induces an electric charge into it. We then send that into a transformer, and that's electric power that you can use anywhere. What that also means is we can then take a gate and put it on the backside of the dam to open and close and change the flow rate through the dam, and that directly changes how much power output we have from our hydroelectric generator.